Hello, everyone. Happy to see as many people as I do on the last session of the day in the dungeons. Um, so yeah, this room is now going to be a room where we talk about DDD. If that wasn't what you were intending to see, you're in the wrong place. And doors are still open if you want to walk out. So, my name is Klug. I work at a company called Active Solution in Stockholm as a software developer. I've been doing software development for the last 25 years, I think, professionally now. And I also do a lot of travel around to conferences and talking about different things, a lot of very different things, and today the topic happens to be DDD. And the reason for this talk was that I went back and I read this book again. I tried reading this book a few years ago, and nothing has ever put me to bed and to sleep as fast as that book. It is drier than dry. And then I picked it up about 2 years ago again, and I was like, I am going to read this, because I really enjoy a lot of the ideas behind DDD. I've seen a lot of talks on DDD, and it's like, I'm going to read the source of truth when it comes to DDD, and it's the domain-driven design, tackling complexity at the heart of software by Eric Evans. So I went and got the book again, and I read it, and it was amazing. It didn't put me to sleep. It's just, there's so many things in there that I read. I just kept on reading. It's like, there's so many really good things in this book. Even though I just checked it, it was released in 2003. So it's ancient in every form of the word in IT. But it's really, really good. And I read this book and I was like, cool. And then I carried on and I read the red book. So that one is generally called the blue book. Everybody knows it because it's the definitive guide on DDD. And then Vaughan Vernon wrote a newer book a few years ago, which is newer and more practical and more into how do you actually use it. And that was a book I really hated. It was crap. I really disliked the book. I dropped it, didn't read it, and then went back and I read it again, and it was brilliant. So I think it's all about your mindset, what you're looking for when you pick up the book, because it was actually really good as well. So reading these books, I was like, there are lots of really interesting things in here that I actually do while building my software, but I think other people could benefit from it. If they haven't read these books or don't feel like reading heavy books on DDD, or maybe feel like DDD might not fit into their world, I can do a little talk on that and show them the parts that I like. So that's kind of where it comes from. But before I get started, I do want to have a disclaimer. Even though my title is very clickbaity, because apparently your titles for your talks have to be clickbaity to get people to walk into your room, I am not going to be bashing DDD. I'm not going to be bashing DDD because I actually like DDD a lot. Now, I'm also not going to tell anyone or everyone that they're going to use DDD or they should use DDD or you're a bad developer if you don't use DDD, because not everyone can use DDD. And I'm not saying that you can't use it because you're stupid. I would never say that for reasons. I'm saying it not to be politically correct. I'm not saying it because of that. I'm saying it because some areas, first of all, DDD doesn't fit in very well. And secondly, depending on what you do for a living, you can't use it. So I'm a consultant, which I really, really love. I get to go to different clients and see different domains. And there's a deal for any client that takes me on as a consultant. I will only be at your company for 3 to 6 months at tops. That's the way it works. I'm not going to be any further than that in most cases. And that means that I cannot spend 6 months trying to figure out the ubiquitous language and DDD things and blah, blah, blah inside the domain. They hire me, I come in and I solve technical things, and then I leave again. So I'm not going to be using DDD in my day-to-day business, but I'm using parts of it for the things that I do for my clients. So, quick recap, what is DDD? Well, it obviously starts with this book. Eric Evans wrote this, released in 2003. I had to have 2 versions because apparently coding in Portuguese is apparently more messy than it is in English. I have no idea why they have a different front to the book. The rest of the world has that same picture for every other thing, but Portuguese comes with messy stuff. He wrote that book and defined the term that we call DDD. And the most important part of DDD is ubiquitous language. So how many of you, hands up, how many of you have heard the word or the two words ubiquitous language before? Okay. Now, how many of you had heard the word ubiquitous before you heard ubiquitous language in DDD? Okay, so a couple. I feel like a complete idiot because I had never ever heard that word before I came into this. So I kind of went, what the hell does ubiquitous mean? It's not a word that you generally use very much. So I went to Google and I put it in there and it gives you this and it basically says, found everywhere. So it's the language that is found everywhere. No, it's not. Not at all. It is the language that is found everywhere in your domain, which is not everywhere at all. And also, it's actually not everywhere inside your domain. It's actually everywhere inside of a small part inside your domain. So it's actually not very ubiquitous at all. But it's called the ubiquitous language because it's a language we agree on. And the whole book that he wrote is about language and the language used in the domain so that we can communicate as developers with the experts in that domain on equal footing. So for example, you talk to what Eric calls a domain expert, somebody in the domain that knows what they're talking about, and they say, well, based on the client's discount, we can calculate the total cost of the purchase. That would be reasonable to hear in a meeting, right? I've heard that several times before. And then the developer hears that, and they leave the meeting, and then that turns into, so once we have the user's discount setting, we can update the total price on the order. Kind of the same thing, right? It is sort of 90% the same thing, but it's not the same thing. And that's kind of where Eric goes in and says, that's not the way that we should be doing it. We should be using the same language that the domain expert was using, which means that we don't change the purchase word to an order, and we don't use a discount setting and things like that. And once the developer then has turned the sort of one way of wording it into this way of wording it, they go and code it, and it turns into this, which then has get user ID, get current order, you get from the discount repo, you get the discount settings, you update the total price, and then you get the total cost. Now, once again, it is literally what the domain expert asked us to do, right? It's what they said. The only thing is, it's not in the words that the domain expert used. It has changed the words in a way that still fulfills the actual request, but if the domain expert looks at this, they are going to have to sort of translate in their head. Oh, okay, so I was talking about a purchase, but you've got an order, okay. And then discount on the user, well, that's probably the discount setting, blah, blah, blah. How about we as developers don't translate what they say and actually do exactly what they say and make the code look like that? Get the current purchase and calculate the total cost based on the client's discount. It's a tiny little change. I completely agree. Code does exactly the same thing, but if I show this to a domain expert that doesn't even know how to code, they can probably look at this code and figure out what's going on, right? And then you can go and say, hey, I wrote this code. Does this look correct to you? Is this what you'd expect? Now, I probably wouldn't go and ask the domain expert about 2 lines of code, but if this becomes a bigger thing, I can actually have a decent conversation with the domain expert, and we would use the same language, which is that ubiquitous language. Now, I'm not going to be talking about the language because I don't have time to do that. I have other things that I find more interesting at conferences than analyzing a specific domain. So I basically came to the conclusion, I'm not going to be able to do a talk on that, but there are other things in domain-driven design except for the language that we can have a conversation about. And most of those are technical things, or as it's called in the book, tactical patterns. So Eric talks about the language, but he also looks at different technical solutions to problems, or as he calls them, tactical patterns that makes our code easier to read and easier to work with. And he talks about things like value objects and anti-corruption layers and domain messaging and things like that. And then he also goes in and talks about what he calls strategic patterns, which are sort of architectural things, not actual down to code things, but what architectures can we use, and how can we organize our code in a way that makes it easier to work with. And one of the most important things that he talks about was what Leila talked about this morning, which is core domains, supporting domains, and generic domains, which is a really good way to divide your application. But then that gets pulled down to bounded context and things like that. And then he also goes in and talks about some generic things that can be interesting that I, as a developer in the .NET world, maybe didn't spend too much time thinking about. Things like consistency concerns. So what's the consistency boundaries of the code that I'm working on, and what can I guarantee when it comes to the consistency of saves and things like that. And he also does a small foray into layered versus hexagonal architecture, which might be an interesting thing to have a look at. And other stuff. There's tons of stuff in that book, for obvious reasons. Now, the only thing, before I get started on talking about technical things, I do want to mention a very important thing. When it comes to DDD, the technical stuff, like the technical patterns or the technical things that Eric talks about, they are just there to support us of doing the other stuff. They are not the important stuff. The stuff that I'm going to show you is not the core of anything. It's just funky, cool things that they've come up with that actually makes code easier to read, for example. So Eric words this quite nicely by saying, the heart of software is its ability to solve domain-related problems for its user. All other features, vital though they may be, support this basic purpose. Once again, coming a bit back to that keynote this morning, where actually we write code to solve problems for our clients, right? I tend to say it a bit more abrasive than Leila normally does, or did this morning. I generally say our code is worthless. The code that we write has no value. And you can fight me over that however much you want. I just want to mention that I'm 2 meters tall, I'm 100 kilos, and I'm a Viking. But you're more than welcome to fight me over that. But I do believe that our code is worthless. However, the code is valuable in the way that it solves technical problems, it solves problems for the domain, but our actual code is useless. It's worthless. It has no value as such. Now, having that said, I do like code a whole lot, which is why I'm doing this. And I started doing this talk, and I started drawing my little PowerPoints, like what am I going to talk about? And I'm going to talk about this, and I'm going to talk about that, and I'm going to talk about this, and this is going to be really cool. And then I looked at my slide deck, and it's like, I just produced a slide deck about object-oriented programming. There's like nothing fancy at all in here. There's just like, okay, so basically what I'm going to go up on stage for an hour is to tell everybody, you know that thing we called object-oriented programming? Can we go back and do object-oriented programming? Because that's not what we're doing today. Now, I'm going to show you some code, but I did this presentation at my office before I did it at any conference, and I got hammered by my colleagues. They all said, your examples are wrong. Which is why I now have a slide that says my examples suck. But it's about the concepts. It's really hard to write examples that fit on a single PowerPoint slide that are complex enough to show off what I want to show, but simple enough to understand and fit onto one slide. Trust me. If you don't believe me, please go and try to write your own code on a PowerPoint slide. Also color code it nicely so you can see it, and you'll understand why it's a problem. The thing that my dear colleagues attacked me for was I have an example of Swedish personal numbers, which is like our identification number in Sweden. I simplified that into a very basic form, and then they started punching on me because we have a NuGet package specifically for that has all the intricacies of this, that, and everything. So my example later on today will now called simplified personal number, and I have a slide here, so nobody can attack me for my demos. I'm sorry, that's just good. You have to accept that. So this is my code. And yes, I did write it in PowerPoint, and I did color code it to make it look like it did in my browser. And yes, it took forever. And yes, every time I find a bug in my code, it takes forever to fix. But it's here, and it works, and it's hopefully readable from the back as well. So how many of you have seen code that is very similar to this? So half the room, basically, and the other half is lying, because we've all seen it. How many of you have written code like this? Half the room, and the rest of you are lying as well. unless you're not in C# land and you write some other, and that might be true. No, this is code that I see on a daily basis in a lot of projects, and there's nothing really wrong about it. The only thing I dislike is that we keep repeating things like this in different places in our code, because validating what you're allowed to put in as a first name is probably going to be a thing that you do in a few different places, and then validating age and things like that. And basically, we've turned the user object into this anemic, stupid DTO. It doesn't have any logic in there, but all the logic is existing in other places around our code base, and we're telling the user that here is your new first name, here is your new last name, and everything else is outside. Not a big fan, and it becomes messy to read. So we could go and pull out the validation logic, because I've heard this before when I mentioned that, and people go, no, I have this validator class that allows me to validate this repetitively in different places in my code, so I can have the same validation in several places. Yes, you can, and if you forget to call that validation, it's gone. So this solves it a little bit. You get this user parameter validator object that helps them validate the first name, last name, age, and things like that. But I am now, once again, forcing, as I said, the user of my code to go and do the validation on their own. So my new junior developer that comes in to help out, he's going to do something that messes with the user object. That person now needs to remember, oh, I need to call that validation stuff over there and not do other validate. It becomes a bit messy after a while. And honestly, if we just take a step back and we realize that we are in an object-oriented world, we could just put it in the setter. Because if you put the validation logic in your setter, you get the same validation logic in your entire code base, and you don't have to tell the user that, hey, when you use my user object, you need to validate these things. The user object is self-validating, which is really nice. There is a tiny little thing here that I do want to mention, because there are problems with this code. This is pure object-oriented programming, and I really enjoy doing it like this. The only thing is that for some reason, a lot of developers do not put try-catch around setting a property. Calling a method, oh, you put a try-catch around that because methods can explode and have problems and cause errors. Setting a property, no, we do that without try-catch all over the place, because properties generally don't throw errors or throw exceptions, because we don't do object-oriented programming and actually put validation logic in there. So you might end up with people not catching exceptions, but it's nice because you get the user object doing its own thing, and we can get code that looks like that. We don't need to call validation logic. We can just go and say, hey, change that thing, and it's nice and small and beautiful and all of that. Now, Eric writes in his book, the beauty of objects is their ability to encapsulate all that, which is code, so that client code is simple and can be interpreted in terms of higher level concepts. And I really like that. I kind of like the fact that using my user object is really simple. I'm not forcing you to understand how to do validation. I'm not forcing you to do a bunch of things before you can use my object. When you pull out my user object, it tells you that you're allowed to set these properties, and validation is already built in. Now, I kind of don't like that either, because it's not very obvious about what you can do and how you set things and so on. So imagine that you always update these things together. Updating first name and last name together makes sense. Age, maybe not so much, but once again, my demo sucks, or my code sucks, so just accept that you do these together. We could make it easier for the user and actually turn it into a method. Because now I'm telling the user of my user object, or the developer who's going to work with my object, that, hey, this is a thing you can do. You can update the personal details. And then there's a method for you to call instead, which is nice and simple and very descriptive. I moved into that, and then I thought that was the business, and then you end up with all of these extra methods that do this and do that and do this and do that, and they duplicate, and it gets kind of annoying. And then you read Eric's book, and he starts talking about value objects. Value objects are awesome in a lot of different ways. So I would assume that someone like Eric or somebody who does DDD would actually look at these three properties and say, they're updated together. They are a value. The age and name of this user is a value. Once again, age is weird, I know. But we just say that they are a thing together. then we can turn those properties, or that value that consists of those three properties, into its own little class, its own little value object. So I create a new class here called personal details. And the personal details class has a constructor that forces you to pass in a first name, a last name, and an age. Inside the constructor, I have my validation logic, which means that it is impossible to create a personal details object that is in an invalid state. Whenever you get an instantiated instance of this class, you know that it's valid because it's passed through validation. And also, it's a record with init sets down there, which means that it's immutable, it can't change, which is really nice because then I can turn my personal details into one property on my user class, and I can turn my code that works with it into that. I don't need an update user blah blah blah. I don't need to do independent properties. I can have an actual value like that, and I know that if new personal information goes through and doesn't throw an exception, it's a valid instance, and I don't have to worry about validation. And if we make it using a C# record, we can also use the with keyword, so we can do, hey, set the user personal details to user personal details with, and then update individual ones if we want to. So it's built into the language using records as well. And some of the characteristics for a value object, there are three really important ones. Value equality. So you always validate the value, or if you compare two value objects with each other, you compare the actual values. You don't have an ID. You don't do instance comparison. You look at the actual values. So for my first name, last name, and age, I would compare the first name, the last name, and my age to do my value equality. Once again, comes straight out of the box if you use C# records because they have value equality built into the system. They are all immutable. You're not allowed to change a value object because when you change a value, it becomes a new value, which means that a changed value object is actually a new value object because it's a new value. Once again, comes out of the box with records. It's almost like they built records around the idea of building value objects, right? And it's self-validating. So it should validate its own information and make sure that you can never create a value object that is in an invalid state. And looking at this simple record here, it's a record, so it's immutable. I have my constructor up there with the validation. I have init sets down there, so it can only be set at creation time. I have my validation logic in the constructor, which basically makes this a, in quotes, perfect value object. It also becomes a perfect value object because of record inheritance, because record, or making it a C# record, means that it overrides the equals method, it overrides the get hash code, and a few other things for you automatically based on the properties on your object. But it's also kind of cool because you can add more to it than just encapsulation. So an example that Eric has in his book, and you can see that in .NET as well, is color. Color is a really good value object because the color generally consists of RGB values, right? 0 to 255 for red, green, and blue. Works like that. So it's a record. You have red, green, and blue. But we can also add things like that, little helpers for us. So if we need to create a color from a hex string, for example, we can have a little static method for that. So we do color from hex, and we pass in a hex, and then it does stuff, and you get a color back. You can do mix with. You have a color, and then you mix it with another color in a specific ratio, and then there is smart color code stuff that I don't understand, and out at the other end, you get another color, which is what you get if you mix two colors, right? So it's immutable, but it gives you more functionality than just saving values. Here is my simplified personal number from Sweden. So I don't know if there are any Swedes in the room, but personal numbers in Sweden are, generally speaking, I want to make that clear, it is your birth date with 2 digits for year, 2 digits for month, 2 digits for day, a dash, and 4 digits at the end. And as I said, in general, then there are a ton of other rules around it that we're not going to talk about. But it basically allows me to do a value object where I do the constructor actually becomes protected in this case. I don't want to create with a new, I'm going to go ahead, and it has validation logic in there, because there are rules around your personal numbers. But instead of having a public constructor, I do have static creation methods called from, where I can pass in a string, or I can pass in the birth date and the digits at the end to create my thing, and then that does all the validation for me, which is kind of nice. Now, what is different between this and what I showed you in the color is that it actually can do other things. So, once again, generalizing a little bit, we can actually pull out information from our personal number. So I can figure out your birth date. Because even though you can treat a personal number as an opaque value, it actually does contain not your birth date, a hint of what could be your birth date, because not everybody gets their birth date depending on how many people are born on one day. It might not fit into that day, and then you get another date. Or if you're an immigrant coming to Sweden and you don't have papers to show your date, you can get another date. Let's ignore that, but you can kind of figure out the birth date in a lot of cases. You can also figure out gender that you got at birth, because every child born in Sweden has a control. One of the 4 digits at the end basically genders the child at birth. But we can also do things like having extra helpers, because we know that this is a date plus some digits, but we generally format it in 2 different ways. In either 12 or 10 digits. It should be 10 in all cases. And then we build that in as well. So whenever you get a personal number back, you can just go to string, and it comes out in the format that it's supposed to be. So you get helpers for that specific value as well. But it can also be very, very simple. So I'm going to have a little quick pop quiz. What's wrong in this code? Anyone? No one? It's coding-wise, it compiles. Yes, exactly. There's the problem that this is obviously wrong, because I was supposed to pass in 5.3 and not 3.5. I passed in the wrong values, right? I turned them around. Anybody have that happen in your own code? Thank you for those hands, because I think we've all been there. It's like, I'm just going to introduce another property or another parameter to this thing, and then you end up with string, 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 int, string, and you go, oh, let's see, now that goes in there. This is kind of annoying, and we can actually solve that with these 2 lines of code. That is, and this is not abbreviated code. This is actually all the code. All you do is public record user ID and public record group ID and int value. And then all of a sudden you have them typed. So now you have to go and say, hey, to create a new item, you pass in a user ID and a group ID, and you won't make that mistake because it's in your face that is what you're passing in. And on top of that, it reads like English. You create an instance of my item by passing in a user ID and a group ID. It's there in your face. This is what I'm doing. Instead of 3, 5, what does that mean? I don't know. And I really believe that if you can write code that reads like, and then I put language in there, which was stupid, I shouldn't have done that, English. If you can write code that reads like English, let's just go there, it makes it easier to reason about, because everyone knows English. That doesn't come out quite as well. But what I'm saying is, if you can read the code like you read any other text, it makes it easier for you to work with the code. Now, I chose English in this case as well, because you have all the keywords there in English. Lots of your code is going to be English, and if you start doing, in my case, Swedish variable names and that, it does work, and it can be really useful in the case of DDD when you can't translate a Swedish word into an English word properly. But the reading situation of reading it like a book or reading it like text becomes jagged when you combine 2 different languages. Which is also why I like this. This came out of another DDD guy from Sweden many years ago, and I haven't been able to let it go. This is pretty common code. You get your users repository, and then you do get by CD, and you pass in the name of the CD. I've seen code like that or similar code a gazillion times. I have a couple of comments about it. First of all, drop the repository on your interface name. Why? A, if you have to put the name of the pattern you're using in the interface, you are probably on the verge of not actually implementing a repository. You've probably built something that is maybe a repository. Otherwise, the interface should tell everybody that this is a repository because you use it to get objects. So you shouldn't have to put repository in the name. And secondly, this pattern is what, 30 years old? And if I asked everybody in this room, I would probably get about 45 or 50 different definitions of what a repository means. And I have spent many, many, many lunch hours discussing this specific pattern and what it means and so on and so forth. If you just remove it, the discussion goes away, and you still get the same functionality because it's still got the same things on it. But I also tend to rename my methods on my users interface in this case to things like living in. Instead of get by city, I go living in, which means that I can go and say, wait, users living in Whoville. It's like reading English. It literally tells me what I'm doing, and you can have a lot of things here. You can have users with premium subscription, users with subscription of type, users living in, users with ages between, and they become English when you read it. And then there's the users with ID that doesn't actually return plural, it returns singular, and it doesn't fit into it at all, and it annoys the hell out of me every time I do it. But I'm willing to take that because all the other ones actually read quite nicely. And then Eric goes in and he talks a lot about the difference between a value object and an entity. And it's an interesting conversation that I'd never had before, and it becomes interesting when you start looking at it. And what my conclusion is after reading his book is that you only need an identity if your object changes over time. It took a while for me to digest that sentence. Actually, the sentence is slightly different, so I rewrote it and called it mine. But if your object doesn't change over time, you never need to give it an identity because, well, if it doesn't change, it doesn't need an identity, then it's a value. Like going from red to green, you don't need an identity for red and green because they're just values. They don't change over time. Red is red, that's the way it works. Green is green, that's the way it works. But once you start having things that you want to track, then you need an identity. Now, identities are still ridiculously important. And that's where the difference between a value object and an entity is. An entity in DDD is an object that has identity, that has change tracking, that has a life cycle, has something you need to keep track of over time that is more complex than just a value. So identities are still really important, but you might not need to put them on everything. Now, the problem with not putting it on everything is the database. Databases love identity on everything. So even if we do red and green as colors, we might have a table in the database that has a red and green as an entry for colors, and then each one thing in the database has an ID because there has to be an identity column in your database, and so on and so forth. Absolutely. And identities are really important, but in a lot of cases, you can actually hide them from your code. We don't need to expose the database identity. So for example, if we take the Swedish person, what's the most natural number or natural identifier, to identify a user in Sweden or a person in Sweden? Well, it's quite obvious that personal number that I keep coming back to. I'm also 100% sure that if I go to the IRS or something in Sweden and I ask them about me, I probably do have some GUID or some integer, probably not integer, it's going to be too small for having Sweden's population, but I probably have some form of database identifier in their database because you don't want to use a 11-digit long string as your database key because it's performance-wise not a great solution. So instead of doing ints and having that, personal number is still my natural thing. So why do I have an ID on this entity? You can change your personal number, but that's a whole different story, and it's a really complex story, and please don't go down that route. I can put you in contact with people. And also your personal number actually changes over time. When you turn 100, your personal number changes because the dash between your year and your last 4 digits goes from being a dash to being a plus. which is really smart that the system is built around the fact that everybody that turns 100, every single system in the world has to change a string and change the dash to be a plus, but let's ignore that. No, the reason for that ID is always the database. If we don't have an integer there, can't have it in the database. You just told us we can't have the personal number as the primary key. Has to be there. No, it doesn't. I just had to put in there. People say, oh, it's just an implementation detail. That is generally quite important still in a lot of conversations. But for this, it's actually quite interesting because you can just remove it. You can make it private, for example. Making it private leaves it there, but it's not visible for the user or the consumer of my Swedish person. And we generally talk to the database using Entity Framework. Entity Framework supports that by basically saying a property of int and then a string, and if you use a string there, it will compare that string to any private field on your class, and then private fields are mapped. That's not a problem whatsoever. So that's not a problem. And speaking of that, you can remove it completely. You don't need to have it at all because Entity Framework actually supports you doing that. Property of int and then a string, and then it creates what's called a shadow property. A property that only Entity Framework knows about. That's not even part of your code, but it hides the implementation fact that your database needs it, and then you don't need to show it at all. Loving that. And also, while on the topic, if you do things like value objects, Entity Framework supports that using complex property. So you can go and say, hey, I have a complex property and I need to read these 2 column values in this table and turn them into this combination instead, for example. And if you have a very simple value object, in this case, like the user ID I talked about before, you can just have a quick hash conversion, and then you can actually query using that entity type as well. So that works pretty nice. So in the end, if we take all of that, we just boil it down to design the objects the way that you want them to look and how do you want them to work, and then you take Entity Framework afterwards, and Entity Framework forces you into some things like having a key for it. Then hide the key as much as you can. Hide anything that you need to adapt because of technical reasons as much as possible, and then leave your code so that when you ask for a class, you get a class that is describing what you can do with it with a self-explanatory API. Okay, so let's zoom out a little bit and not focus too much on the little nitty-gritty stuff. How many of you have seen this before? So once again, half the room, and then the other half flies because we've all seen that, I think. It's one of the most common things. Oh, we have a layered architecture. You have a bit of database, and then some stuff there, and then some. Sure, that works. Now, interestingly enough, if you go and look up a layered architecture, that is actually illegal. So your business logic can never talk to your infrastructure. So if your business logic ever needs to send an email, for example, you can't actually go and talk to the infrastructure because of layered architecture doesn't allow that. So if you want to send an email, you would have to go through the business layer to the persistence layer and then send your email from your infrastructure. If you look at what the definition of layered architecture means. Now, nobody cares. We couldn't care less as developers, so we basically went and said, we'll do that, and then we'll just rename it to a relaxed layered architecture, which is another architecture which basically says, we like the thing you had before, but it was too annoying, so we just ignored it. Now this kind of works, and DDD talks about that. They renamed the layers a little bit, so instead of business layer and persistence and infrastructure, they call it application, domain, and infrastructure instead. So your application and domain doesn't have persistence, but you put persistence into your infrastructure. And that's all fine and dandy until somebody comes and says, hey, messaging is kind of cool. We should support messaging. How do we do messaging? Messaging comes in through the infrastructure layer. You get your message into the infrastructure layer. The infrastructure layer looks at the message and says, oh, I need to call that application layer and tell it to do something. Now you can't because you're not allowed to talk upwards. Now, there is not a relaxed layer architecture where you're allowed to do whatever you want. So we can't just add other arrows. That's not the way it works. So Eric solves this in probably the ugliest way I have ever seen, but it's still very much what we do, and it doesn't actually solve the problem either. But he says, let's do this. Let's put the infrastructure layer just underneath the presentation layer. It irks me. I don't know, it looks completely wrong. And it solves the messaging problem, because it means that the messaging comes into the infrastructure, talks the application to the domain, but then the domain needs to persist something, so it needs to go up to the infrastructure, and we're not allowed to do that either, so that doesn't work either. So the solution to that is to do that according to domain-driven design, which is you put the infrastructure layer fairly high up in your architecture, and then you inject it into the lower layers. So the domain layer, for example, defines an interface of what it needs, and then your infrastructure layer implements that interface, which basically means that your domain layer never actually talks to the infrastructure directly. It only talks to the interface, but the interface is implemented further up the stack, and apparently that's okay. I don't know. That works fine. I don't build like that, and I think most of us don't look too much at this either. Most of us actually end up building something like this. This is hexagonal architecture or onion architecture, or I think the official initial name is ports and adapters. And the idea here is that you basically have a bunch of different ports. So ports are different ways for you to communicate with your application. In this case, it could be a browser. You're browsing the web. There could be a REST client if you have an API. There could be a gRPC client if you support gRPC. It could be a queue coming in. But basically, you have different ports. On the left-hand side, your ports are input ports, stuff coming into your application. The ports then talk to adapters. The adapters take whatever that comes in. So for example, the gRPC port looks at the gRPC message, pulls out the information from the gRPC message, and turns that into something that can be understood by the application services, which is one layer in. The application layer then, or the application services then talks to the domain model, which has domain objects and domain services and things like that. And then going back out again, the main model talks to application services that talks to adapters, and then basically can do stuff. Now, it's kind of the same thing. It's just they did it a round thing instead of a pancake layer thing, basically. But you do end up with these hard lines once again. So application layer is allowed to, application is allowed to talk to application services, so you're allowed to talk inwards. And application services are allowed to talk to the domain model. And then you solve the whole, hey, the domain needs to do something by declaring an interface in your domain, so your domain only depends on its own stuff, and then we do the dependency inversion and inject an implementation when we need it. Now, that means that we can go and say, hey, my domain needs an email service. The implementation of the email service is done in the application services layer, and it's called M365 email service, for example. It talks to an adapter that talks to M365. And in theory, we could go and say, hey, as an application service, I need to send emails as well. So I could use, my application service could go and use the iEmail service from my domain, but a better solution is actually adding another abstraction on that layer, another interface at that layer, and then have the M365 email service implement that interface as well. Now you get a really nice separated model where application services talks to its own services and to the domain model. The domain model only talks to itself, and the application talks to application services only, which has just nice watertight barriers between the things if you can. Just going to plug in some power here because my laptop said that it's dying. So looking at going from architecture and going a bit further back. So there's a lot of talk about domain in domain-driven design for quite obvious reasons. Now, how many of you are consultants? Oh, that's a decent amount. Okay. How many of you have walked into a client, heard them talk about the domain, and felt, oh, I have no idea what I'm doing. I have no idea how I'm going to understand all of this. This is completely new to me. I'm going to be the first one to say that happens basically for every single client I ever walk into. And it terrifies me. And there's this old saying that says there's only one way to eat an elephant, a bite at a time. And that is a really good way to do it. You take one little chunk at a time, and over time you take the thing that you understand and you implement that, and then once you have understood that, you probably understand a little bit more and you do more of that. Now, DDD has a very structured approach to this of how you divide your domain. They divide it in two ways. So there's the thing from the keynote this morning that talks about different domains. So And domain is a very interesting overloaded term because you're in the customer's domain or in the domain that you're working in, and inside that domain there is another domain, and there are different types of domains inside of your domain. They should really come up with a better word. But we've got the core domain, which is the part of your system or the system that you're working on that I think the comment from this morning was makes the money. Is the thing that you can charge for, the thing that is the reason that people come to your business because that is what you do really well. But then you have the subdomains. So in this case, you have supporting subdomain. This is a domain that it's required for you to have your application running, but it's nothing special and it doesn't actually really make you money, but it's complex enough that you can't just go and buy it off the street or download a NuGet package. And then you have generic subdomains where it's basically saying, hey, we need these things as well for our core domain to work, but it's something that somebody has already solved to the point where we can just go and buy it off the shelf. So identity management is a very generic one of those that often work like that. You can either go and say, depending on what you're building, hey, we can use Active Directory, that works fine, or we can go and say, hey, Auth0 or Entra ID will solve it for us, we don't have to build that. Please, for the love of God, never go and build an identity system unless that is your core domain, because it's just dumb. So if we take an example, for example, an eShop. Say you're building an eShop online, you're going to sell something. Your eShop is going to be very unique. That's your core thing. You're selling eShop software, and it's like, that's the important stuff. Also need a loyalty program, and I need some user management. Now, my eShop has some very specific loyalty management system, loyalty program systems stuff, and I have a very specific user management system. I just said, don't build your own identity management system. And then I said, we need to build one. But say that we need to do that. So I would build those. Those are supporting because I can't buy them off the shelf because my demands are very, very weird. And then we have inventory management and newsletter management. Those are supporting or generic ones where I can basically say, hey, inventory, there are online systems that I can integrate with. They do that, and that's their core domain, and they do it really well, and me building it would just be dumb. And then newsletter management, once again, have you ever tried implementing that? Don't. Go and buy it. There are like 600 different companies that you can go and get newsletter management from, and they will do a much better job than you ever will. So we can go and buy those. That's our generic subdomains. Now, you have that ubiquitous language, which is in the whole domain, but it's not. Because your ubiquitous language is unique inside of your subdomain or your core domain or whatever. But it's actually not that simple either, because it's actually unique within your bounded context. So bounded context come into play when a specific sub-core or sub or core domain is too big for one single development team to build. And the reason that that is a problematic thing is that you can't just throw two development teams on something in DDD, because the entire development team needs to agree on the ubiquitous language. And once you need two teams building on the same thing, then those two teams need to agree on the different definitions of things and the different words inside of that bounded context that they're working on. And teams can never agree on anything. So the better idea is to say, we're going to split this domain into two separate bounded contexts, with one team working on one bounded context and they have their ubiquitous language, and another team working on the other bounded context and they have their ubiquitous language, and then all they have to agree on is basically how you translate between the two different languages and have your conversations. Now, defining subdomains and bounded context is complicated, and you will fail, and it's the hardest thing you can ever do. And if you do it early on, you're probably going to have to redo it a couple of times because you've drawn your lines a little bit wrong, and you realize, oh, this thing actually belongs over here, and it doesn't belong there, and things like that. It is complex. That's just the way it is. But I think the main thing, if you're not going to go down the whole bounded context thing and all of that, at least take a step back from your application, have a look at it, and go, are there parts of this thing that we can literally outsource and buy from someone else? Because it's generally cheaper depending on what you're buying, right? And the other part, is there anything we can sort of shovel off to the side that is less important? Once again, keynote this morning, stuff where you can use AI, basically automate things because it's generically previously solved stuff. and then focus on the thing that's really important. Now the problem is that when you start splitting things out, you have to start communicating. Communication is hard. And communication is hard not only between humans interacting, it's actually hard between technologies or tech stacks as well and different applications. So for example, you're working on your domain over here where you're working with orders and order lines in your eShop. And then you have this other supporting subdomain that someone else is building, but they have decided that they're going to build a really generic system where they don't have order and order lines, they have items of different types. And then items can refer to other items and blah, blah, blah. That works really crappy from a performance point of view, but it's very flexible. So that's what they decided to build in their team, and then these all of a sudden have to talk. Now the problem with that is that in my domain, I have to use this supporting domain, for example, and then I might end up having to do this. So I create my order service thing, and then, oh yeah, so I need to talk to the supporting subdomain, but it has a different way of representing things. So inside my order service, I have to replicate their way of doing it and create little like to item and from item extension methods or something to basically take their model and turn it into my model, and from my model into their model for it to be able to communicate. Which is kind of annoying and dumb, and it causes problems because when the supporting domain here goes and says, oh, we changed our model, now you have to change your model, and you have to make changes to all of your code. And then all of a sudden they also go and say, oh, by the way, you need to do 4 different calls to be able to get an order because we decided that that was the way to do it, because you need to do 1 call to get the order, and 1 to get the order lines, and 1 to get the delivery address, and 1 to get the invoice address. Now you have all of that stuff in your order service, and it gets annoying and ugly, and it basically destroys your beautiful world that you're working in. And we often see, like when we see the multiple calls, we as developers tend to do this very, very quickly. Oh, I'm going to turn that into a service that does all the calls for me, but I'm still in this case leaking the entity type from their domain into my domain. And also, what we want to do in DDD is put an intention revealing interface on our service. So basically, like I said earlier in the talk, have method names that make sense. You should be able to pull up an interface, look at the methods, and understand clearly what they're doing. So we put that on top of it, but we're still stuck with leaking item and item types into my order service because I need to talk to their system. And it's not a great thing. That's where they start talking about anti-corruption layers, which actually sounds a lot cooler than it really is. So an anti-corruption layer is just this idea of putting something in between that knows about both of the domains, but does the translation for you. So in my domain, I talk to the order management anti-corruption layer, and that thing knows about my way of looking at the world, their way of looking at the world, does all the translation, does all the method calls and all of that stuff. But in my beautiful organized domain, I don't have all of their crap. And when they go and say, hey, I'm going to go and change this, so this thing here is now not going to be called an item, it's going to be called something else, I can go to my anti-corruption layer, make a change, but it doesn't affect any code in my domain. That's all an anti-corruption layer is. And then communication, once again, all of a sudden we go in with synchronous versus asynchronous communication, which is a very interesting conversation to have. Once you start doing asynchronous communication, your life turns pretty crap. Because asynchronous communication is hard. It is, if you're shaking your head, because I saw a shaking head there, asynchronous communication is hard. And once again, I'm willing to fight you on that. Asynchronous communication is way harder than synchronous communication. It's less error prone. You're not going to have weird cases where connections goes down and everything like that. So it might be more secure in that way. But it is much more complicated. And as developers, we tend to go, synchronous is the shit. We want to have ACID-based transactions going to the database, and that's the thing that defines everything, and the world is great if we can do it like that. And we need strong consistency everywhere. Typical thing from any developer is strong consistency needs to be there because the client requires it. And then you talk to the client, and they go, well, there's this batch job that runs every night. So you're saying that we do stuff the entire day, and then once every 24 hours you sync these systems up? Yes. Strong consistency is not something we need. We can shove that out the window. And most businesses actually work on an asynchronous model to begin with, but once you go into code, developers tend to turn everything into a synchronous thing for different reasons. And that means that we have messages that needs to be sent around when we start doing asynchronous work, which is kind of cool. And there are two different types of messages in DDD. And the first one is the one that we generally see. It's like all the stuff that goes around between microservices and different services to notify, hey, I need you to send an email, or this change happens, you need to update your data for this user, and all the things that we see for integrating between different systems. We've all seen that, that's fine and dandy. What I like about DDD is that they have what they call domain events, which are also messages, and they can be asynchronous on the wire through some form of bus, or they could be just in your project as well, or in your process as well. But they're different. They're like small events that your application raise or send out whenever stuff happens, like account created, order completed, user account tier changed, and things like that. Little things that just notify, hey, this happened, this happened, this happened. They really small things, but they're actually kind of cool. So when you do things like that, you change the account tier for user account, you just raise an event, it just goes out. And maybe in the beginning there's one little thing listening to it, maybe there's no one listening to it, to be very honest. But then somebody goes and says, hey, when people change their premium accounts to something else, maybe we could get them to keep it if we gave them a discount. Well, we have that user account tier changed event for that, so we'll just plug in and start listening to that event. Whenever somebody changes account tier, we send an email, say, hey, here's a discount for you. Or wouldn't it be cool if we could send a voucher to everyone that buys a blender this week, which, by the way, would be a really annoying thing to implement manually. Here you just go, hey, there's this order completed event. We just take that, we check out what was in the order. Hey, a blender, let's send an email and say that they get a voucher. Very, very simple. And we can prepare for that in our system by having these little events that we can listen to. And then that becomes obviously a conversation about strong and versus eventual consistency, and DDD talks a lot about that. Like a big part of the book is actually about aggregate roots and how you take one entity and you do your work from that entity on. So your repositories are only available for aggregate roots. So you pull out an object, you make changes to that, and you save that object. That's all you do in, for example, in an API call. You do one thing, and that is what they call the consistency boundary. It means that any change you do to that aggregate root is what's going to be saved when you save your changes, and it's going to be guaranteed that anything in that object or any of the objects underneath it in that object graph is saved as one transaction in one consistent way. But if you make changes to two of them, all bets are off. Then you have to do your own manual thing to make sure that they're saved. But it basically, the idea is that here is an object or a few different types of objects that we always start our work with, and then we save that object as a transaction, and that's the consistency. We know that that object and all the child objects on it will always be either saved or not saved. Now, I don't think you should go with aggregate roots and go through all of that. It's to begin with, but at least take a step back and look at consistency seriously. It's like, what happens if somebody pulls the plug to the database at this weird microsecond here? It's very easy for us as developers to go and say, that's not going to happen. Nobody's going to kill the database in that millisecond that it causes a problem. But we probably should think about that. And then the question also often comes up with, what about consistency with messages and domain events? So how do we do that? Because if I take a change and I have a transaction around saving my entity to my database and then send an event to the bus, what happens if the bus is not available? It's down. Well, now I have a transaction that completed around my entity being saved, but I didn't send the message. Do I roll back my committed transaction or try to undo my transaction? Well, that's going to suck if the database then goes offline. So now I'm stuck in this weird thing where I did a save, but I didn't send the event. How do I solve that? Or even worse, if the network goes down in the middle of sending an event, because now you don't know if the event was actually sent because the network went down after you managed to send your information, or if it went down before, so now you're in this like, I have no idea what to do now. And then we can go and say, hey, let's put the event sending inside of the transaction. That's a great solution, because now if the event doesn't go away, I'm not going to commit my transaction with my entity. That is sweet, that solves all my problems until the database connection goes down, because now you've sent the event, but you haven't saved the entity, so now you're in an inconsistent state again. Now, you do that using something called the outbox pattern, which is very nice. You save your entity together with an event to the database, and then you have a separate thing that looks for those events in the database, so you know that your entity and the event will always be persisted, and then you have a thing that makes sure that the event is being sent later on in a safe way and can do retries and things like that, and it's built into a bunch of things. Don't go and build your own. There are other solutions to help you with the outbox pattern. But it's kind of nice. It solves that problem. It doesn't add another one. It's like, doesn't that introduce just a different problem in a different place that actually could mean that you publish your message more than once? Yes, it does. And that's the way messaging works. So you have to do things to figure that out with deduplication and sessions and things like that. But it at least makes sure that you can get your events being sent at least once. And then I do want to mention, honorable mention on CQRS, because it fits very well with domain-driven design, because the right side of domain-driven entities are often very, very different from the read side, from what you want to get out of your entities, so they might look very differently. So instead of trying to do all in one thing, do have a right side with domain aggregate roots and all of that stuff, and then you have a read model that has more normalized data that you can actually read and do in a useful, simpler way. Then, do we need 2 data stores for CQRS? No, you don't. I'm going to keep that very short. We can have a long discussion about that as well, but no, you really don't need to have 2 data stores for it. You can do it in one. And also then the question is interesting. If we have 2 models representing the same thing, we have a read model and a write model, and they represent the same thing with the same kind of objects in there, aren't we violating dry? It's an interesting question, and I would say, first of all, no, and second of all, this is my personal opinion, but you can take dry and then just remove it. We are too focused on not repeating ourselves to the point where we tend to couple everything together, because once we see 2 lines of code doing almost the same thing, it goes into a common library, and then we share that library, and then, oh, this thing also almost does the same thing, so we put an extra parameter on that method, on that common thing, and then we end up with this ridiculously complex helper method, just because we didn't want to have 3 lines of code in 2 places in our code base. I'm not a big fan of dry. I think the intention is good, but we can violate dry quite a lot more than we do today without causing problems, in my opinion. And finally, I'm 1 minute over. The goal of this, Eric defines that really well. The goal is that not only can a developer understand what the code does, he or she can also understand why it does what it does and can relate to the ongoing communication with domain experts. Basically, write code that people can understand and make it hard to do the wrong thing with the code that you're producing as a consumer, and make it easy to do the right thing. So when the next developer comes in and looks at your code, or even more likely, you come back and look at your code 6 months later, you can understand what your code can do and what you should be doing with it without having to dig through 6 million lines of code to figure out what it does. So thank you all for listening. I will be around if you have any questions. I'm going to be in the Brokers as well, so just come and say hi if you want to have a chat. Don't forget to do the evals if you really like the session. If you didn't like the session, come up, tell me why, which is nice, and then I'll tell you why it was great, and then you can go and do a green note. Thank you all.